BSides DC would like to thank all of our sponsors, and a special thank you to all of our speakers, volunteers, and organizers.
Hi, I'm Stuart McMurray. Thanks for coming to the talk on a Sunday afternoon. This is actually usually after hangover time, so I think we're probably good there. I'm a red teamer at IronNet. Pardon me. I'm getting cold apparently. All right, let's try this again. Hi, I'm Stuart. I'm not carrying the plague, as it turns out. I'm a red teamer at IronNet, sort of doing Unix and networky things. Twitter, GitHub handles, that's a Twitter QR code. What you really want to do is point your phone at a QR code that a hacker puts in front of you. Worth mentioning, I'm not affiliated with Nmap, tcpdump, Wireshark, or really anybody whose great tools we're going to be using for this talk. Real quick, can the guys in the back hear me? Mic is maybe... I have an up button. I could just shout. So where's the... Mr. AV Man, is there a... Yeah, I've done that about 6 times. Put it higher on me. I thought about that. All right, can you hear me in the back now? Awesome. Thank you, Mr. AV Dude. All right, so now that we can hear me, we get to the important bit that the views, my company would like me to tell you that the views in this talk are not my company's views. Also, when you're doing networking sniffing and injection and whatnot, it's, you can do some things that maybe you shouldn't do without telling somebody, so consult the appropriate authorities and don't just start watching a network without, or shoving things onto a network without asking. So before we get into this, what is libpcap? It's what underlies, there we go. It's what underlies Nmap, Wireshark, bits of Nmap, Wireshark, tcpdump, so on and so forth. It really is just an API, a nice abstraction layer over layer 2 sniffing and injection. The genesis of it was in the 80s at Lawrence Livermore, and they were like, hey, we have some bugs in, just ARPANET at that point. We have some bugs in our network stack. We don't really have a great way to watch it. Like you can hook up a debugger to code, but it's not really so much on the network stack. So like, all right, well, we'll just write an API. And nowadays what it does is it abstracts away the low-level interface to your network card, low-level programmer interface to your network card to a nice little platform-independent, well, interface. You can use packet sockets in Linux. So you use BPF devices in the Unix world, in the BSD world. On the Windows world, it uses NDIS. It's a little wonky on Windows. It supports like 100-odd platforms. It's really cool. It's a C library. Just about every language I've looked at has some sort of foreign function interface for it, to varying degrees of ease of use. And if you're, just further reading, tcpdump, Nmap, GitHub, Google's Go packet library is quite nice in the Go world. Scapy is really cool. It just gives you a Python interface to almost all things network, so it's really easy to just test things, proof of concept things. So what we have, all right, we have our power strip mic'd. So what we have graphically is we have our application, just my pointer. Cool. So we have our application sitting there and it's attached to the NIC. Notice the firewall is here. So what we have is comms come in over here. Our PCAP application gets notionally, not in real life, it's not actually exactly like this, but notionally you get frames from the NIC and you can do whatever else in application land and then it handles the kernel and the firewall. So it sits you outside the firewall. It's almost like NIC level access to the network, which comes with some ups and downs. All right, so why would we want to do this? What are the ups? Well, on the C2 side of things, on the red team side of things, HTTP is well known. It's really easy to use. There's libraries everywhere for it. Unfortunately, defenders know it very well. It's very easy for them to look at. There's libraries everywhere for it. So it's, it'll work most of the time, especially if you domain front out. You'll probably win, but every so often it's like somebody is looking really hard at that. Speaking of domain fronting, that actually works really good just about everywhere. Except when the provider turns off your thing. It was a Friday, I was giving some demo to some math nerds using Google's DNS domain fronted to YouTube. The Monday I was like at a client side, oh dudes, I got this great demo, here let me show you, and it would not work. I was like, yeah, DNS over YouTube. So, just roll your own, works quite well. You could use DNS tunneling for C2. It's quite nice and slow. Sometimes it gets caught pretty easily if you want to go fast. So, maybe just roll your own. On the sniffing side of things, not the injection C2 making comms, there's a lot that happens on the wire. If you just sit and watch a wire, if you just TCP dump on a box you pop, there's like all sorts of good things there. It's on a box once, I was like, hey, I wonder what's on here, and I found LDAP. just kind of normal on a Linux box. And I found LDAP was using hashes, like just sending hashes in the clear, which is not great, but kind of normal. I found those hashes were des, and I'm like, hey, I'll just wrap tcpdump and grab some hashes. So worked pretty good there. And you can just kind of make your own little bespoke ettercap or bettercap or arcane enable or whatever without the fuss or the signatures that brings. And on the sniffing side, we'll see in several slides later, it'll give you some comms. Like you can do comms but without actual network sockets-ish, just a packet socket. Also, I've just fiddled around with, we'll just say send out packets, but with a source that's not the box. The defenders are like, hey, where'd that come from? And you're like, I don't know. Sorry. You can just totally roll your own protocol pretty easily, and the defender's like, hey, IPX, that doesn't exist anymore. And you're like, you're right. More importantly, none of this shows up in netstat. So host-based defenses are like, easy. Well, that's cool. This is one of those talks this morning. All right. So that's me right there right now. How do we use this? Man pages are your best friend. tcpdump's man pages are actually really good. They're really helpful. The OpenBSD man pages for PCAP actually are quite well. Are quite well done. Failing that, just a quick Google search. So using the library, stepping through the API, it's C, right? So that's like 6 function calls later, and you're like, hey, I could have done that one line and go. But 6 function calls later, first thing we do is we attach to an interface. We say, I want to sniff on this interface, or I want to inject through this interface. PCAP Open Live is one way to do that. We'll see the other one in a second. You give it the source interface, you give it how many bytes you want to grab off the wire at once. Promiscuous mode was cool back when adapters were like, hey, I don't care about this packet, so I won't tell the kernel. Nowadays, we don't really do that so much anymore. Give it an error buffer, handle errors. By the way, as I go through the API calls, I'm just going to skip mostly over how you do them, the examples. Slides are on Twitter, so if you would like to go back, the great reference, it's about what that looks like. The other way, aside from attaching to a device, the more modern way is using PCAP create. So you create your PCAP handle, tell it what to attach to. Set some options. You can set the promiscuous mode, or if we're going to turn on RF monitor mode for aircrack-ish things. You switch it on, activate it. Looks like this in more or less in real life. So we're going to attach to EM0 and set the snapshot length to 150 bytes. So maybe we don't care about the rest of the packet, and turn it on, activate it. All right, one of the nice things that PCAP gives us, or the underlying subsystems give us, and then PCAP just wraps it nicely, is it's actually a virtual machine, believe it or not. It's like a bytecode interpreter. That bytecode will determine whether or not the packet's processed, so sort of a fail early, return early so you don't have to process everything. Reduces your processor load, which means that your malware is less likely to get caught. You just send it in as a string, and it's the same BPF filter we give to Wireshark or TCPdump, TCP port 80 and source address, whatever, or source host, whatever. So you set it on the PCAP device, compile it, set it as a filter, and then free the memory, C being not garbage collected. This is what it looks like, so compile it. We'll just look at TCP port 80. You get layer 2 frames when you tcpdump, or excuse me, when you libpcap. You get layer 2 frames, so one of the things you have to do is figure out the layer 2 size. You almost never care about that. You might, but you almost never do. And also, you're not really guaranteed to get Ethernet. It turns out that if you're dumping on loopback, you'll get a different size layer 2 header. If you're dumping on any virtual pseudo interface, you'll get a strange layer 2 header. So PCAP data link, valid name and description will give you a nice way to get that. Looks about like that. Okay, so now we've done the legwork, the boilerplate, so to speak. We've attached to our interface. This is the interesting bit, so we'll loop over it. So we give a callback function. That's where our application stuff actually ends up, and looks like that. So you're taking a user, because it's C, just like, hey, give me the memory I need, and it'll give you the packet header as well as the packet bytes itself, starting with layer 2. So you write that and you start looping and handle packets as they come in. Looks like this. The return errors are a little weird, but it works quite nicely in real life. And then a handler looks something like this. So we'll look at maybe we'll get the length of bytes on the wire, or excuse me, the length of bytes on the wire, the length we've captured. They're not always the same. So you might get a truncated packet, heads up for that. Last thing we're going to look at, PCAP inject to send packets onto the wire. This is how you make your strange protocols, or this is how you're like, hey, here's a packet from an address that doesn't exist. Hope you don't mind. It's really simple. You give it some memory and the PCAP handle you've created, and it puts it on the wire. So you're responsible for all things layer 2 and layer 3. And it just goes. So it's pretty unforgiving if you do the wrong thing. You can oops a network, so don't do that. A couple other handy things when you're writing this. PCAP lookup dev will give you a capture interface. If you don't know what or PCAP final devs will give you the capture interface. In the Unix world, it's easy. It's ETH0 or EM0 or something. In Windows, the interface names are very long, and they have friendly names like Ethernet Adapter Pro 110 gigabit, or they have like UUID, or GUIDs, I guess, in the Windows world. They have UUIDs on them. So those, and you can give, especially with find all devs, you can give your user like just, hey, select one of these adapters. Being layer 2 and layer 3 is up to you. Packet checksum calculates a nice little library. It'll calculate your TCP, UDP, and ICMP checksums. So you just like say, hey, here's my packet, go. And it'll add the checksums in there. Scapy is worth mentioning again. It's a library that takes care of just about all this for you. So if you're proof of concepting things, or I had a dude who's like, hey, can you like actually really send data out with ICMP? And I'm like, yeah. So Scapy. When you're processing packets that you get when you PCAP loop in your handler function, instead of having to calculate offsets to the various header bits for your manually, most Unix systems, and I think the PCAP library in Windows gives you a whole bunch of structs that you can just point memory to. It's like, hey, struct starts here, and that's where your offsets are. So it's really easy just to grab, like, take struct IP, and it's the IP checksum or something to grab it out of there. All right, so notionally, we've written some code. How do we actually use it? Compiling it in is pretty simple. Just link in libpcap, like you'd link in any other library. It's lpcap. Assuming your import paths and whatever are set up on Debian systems, Debian-based systems, you know, apt-get pcap dev or libpcap dev or whatever. Sometimes installed in the target world as well. So when you put a thing on target, it's good to say, hey, is this, you know, is pcap actually on here? Just statically link it. It solves those problems. Statically link PCAP into your binary. It's just a library that wraps a system call, so whatever. PCAP sources are at tcpdump.org, latest releases. It's not a bad idea to grab the latest one so that you know that your PCAP-enabled application malware is using the version of the library you expect. A couple tricks in C that I've come up with. Compile time config, just use macros for that. D-thing, D-something, D-interface, D-device. Is a great way to set a device. If you know what's on target, but you don't want to have to do some sort of like config file or like just guess at the right interface. And it's also really handy to use a constructor function. If you're shoving a shared object into memory, a constructor function is a great way. Just fork a couple spawn a couple threads, and it will save you a lot of pain. All right, so now we've built it notionally. There's a couple ways we can run it. Standalone binary, if we're going to just run it as a program, as a process, you typically need root. On Linux, you need capnet raw. On Windows, depending on how the library is installed and interacts with NDIS, you might need administrator, you might not. It's a good idea to drop privileges, especially if you're taking a PCAP or a BPF filter from a user, because compiled bytecode is always a great place to find exploits. And when you put it on target, it's not a bad idea if it's a Linux, Unix target to run LDD on it and see if the libraries are actually there. And if it's not, it'll say, hey, library missing or library wrong version or whatever else. Then you build it statically or bring your own. Use LD preload for that. If you're using it as an injectable library, if you're shoving it into something, whatever process is running needs access to whatever underlying mechanism PCAP used for that target. So if it's a Linux box, you need that process to be able to make a packet socket, which is not universal. Pretty much anything that starts on boot will. Cron, systemd. Systemd is interesting to inject into, but that works. Containers get kind of funny because of how they interact with interfaces, so make sure you're preferably not in a container environment, or maybe you're just sniffing, that's fine too. I found out when doing this, if I either pre-thread create or just fork and fork, it solves a lot of problems. Still pretty hard to see. If you inject into syslog and you have another syslog process, nobody's really going to notice. Or if you have another thread, nobody's really going to notice. If you're just like taking over a process, it gets kind of funny. If you're using LDSO preload to inject, and you're doing something like catching a trigger packet, or you're sniffing something, it's like sniffing the wire, turns out that loads into every process. So like 600 callbacks later, you're like, oh, hey, maybe I should not do that. LD preload can get you around that nicely. All right, so we'll have a quick demo. We'll just send hello world as a layer 3 payload. So like instead of IP, we'll just have hello world, and we'll send it to the broadcast interface. What we'll do is we'll use a preprocessor macro to select the interface we're going to use, so we're not going to have anything runtime selecting it. And this will all work in as a constructor function. So we inject it, the constructor function spawns a thread, I think, as I recall, but there's no main function, so it's a little weird like that. There's a source for the little demo. It's also online as an ASCII cast. And it looks like this. So we'll pull PCAP down, unpack it, compile it. This is unfortunately what happens when you build libpcap. I found that just about every one of these I've looked into has been okay, but it's not necessarily what you're hoping for. So we'll build down the source, save it as pcap hello world, and this is what it looks like. So what we're going to put on top of our Ethernet frame, hello world, we will, hey, go back. Well, we've defined a device with the macro, so we're going to pause in time. And then this is how you roll a frame. So we'll just, make a buffer, a pretty large, where'd it go? Here we go, we make a buffer. It's just enough size for an Ethernet header and our hello. Hello, it says define macro, sure. We'll cast that, or we'll point that at an struct ether header, so we don't have to figure out where to put in the source and desk MAC addresses. So we do that, just like that. It's pretty easy. We'll set the ether type to chaos, just in case somebody has a Lisp machine running around, and copy in the hello. So open a device, pcap open live, just like that. That's eth0, I think. Send it out with pcap inject, and that's it. Notice that was in init, or in a constructor function. Main just returns. So that way, it's a nice little trick so you can use the same code as an injectable library and as a standalone binary. There we go. So we'll build it. It builds nicely. It's there. It's a shared object. So we built it with, never mind. Where are we shared object? Anyways, it's dynamically linked, so we have to make sure that libc and whatever else are on target. But we linked in statically pcap right there. So it's a nifty way to not have to deal with entire static linking, but you get your library in there. Alternatively, we can build it the hard old school way as a library. There we go. But still libpcap is there even though it's a shared object file. Just nifty way. And we'll tcpdump in the background. So we'll look for anything not IP because chaos, or IPv6. And we'll put that in the background because tabs are hard with eskinema. Run our little thing, there we go, and we see that tcpdump says, yes, there is some strange ether type. We have a hello world out, and that's injection in a network. It's really quite simple. Shove it into a library as well. Notice it goes into the library, it works, but because we set it as a constructor function, not in main, works quite nicely. Downside, of course, is it's a little easy to find if you're digging through memory maps. So there we go. We'll close that, and it's like it never happened. Cool. That's the demo. Okay, so that's cool. It's a neat little demo. You can put hello worlds on the wire. You can make your blue team wonder what on earth you're up to. There's a couple actual useful things you can do with it. So number one, sniff the wire. I mentioned when I found that Unix box with LDAP. By the way, I had 16,000 different sets of creds off of that. It was awesome. Which also meant the blue team, when I was using them, I was like, hey, what if I just try them all? I was like, what are you doing, dude? But anyways, we'll just sniff the wire. And nowadays, most things use encryption, they say. It turns out they don't, actually. Turns out banks really like FTP to send transactions, batch transactions between each other. Not SFTP, not FTPS, just FTP. So if you're on a box where you can see this, you're either on an endpoint and you can see the endpoint comms and that's your FTP or something like it, or you just found yourself on a router that's running some friendly version of an OS that you can shove code into, see what you can find. So we'll have a very contrived scenario here. One of the things we're going to do is we're going to narrowly filter. One of those days. We're going to narrowly filter just to look for push packets. So no SYNs, no UDP, nothing like that. And that just keeps the resource consumption low, especially if you're on some small routing device. You don't really want to do that. Tools that do this already, tcpdump and dsniff are very old. Same with tshark, very old. And they, you can wrap it pretty simply to do most of this. Sometimes you want your own bespoke code. We'll use this tool called Telnet Watcher. It's online. There's the source. And it watches the network. Actually, I wrote it when I had a Telnet honeypot going. I was like, hey, I wonder what these dudes are actually doing. So yeah, we'll just watch Telnet. tcpdump will work in a pinch. It's written for OpenBSD. You can compile it for other things fairly easily. But I've learned not to put malware straight usably on the internet because it turns out it gets used. SSH worms are really popular, by the way, just to let you know. So our little cookie scenario here, we've landed on a host. It's FTPing batched financial transactions off, and we've got root. It looks a bit like this. So we're there's some transaction transfer box running an FTPD, and our lead hacksaws, we're on this box, and there's some bank and SSH comms going to be around there. So, There we go. So we're on target as root. We'll just start this thing. You can get whatever options. In real life, you probably want most of these to either be good defaults or baked in at compile time. But we'll watch port 21. We'll watch the interface VIO0. If we were making a BPF filter, that's what it would look like. We're not, obviously. So there we go. And we see somebody's already starting to come in. So we see Banker Joe and his neat password. So that's already a win. We've got a transaction. We've seen him batching some transactions. That's cool. So that's neat. We can also do something like this. So we take, we just happened to find that an ID RSA key. We found it mount root, so probably somebody doing something funny with NFS. And we'll just exfil that. We'll use Tailnet Watcher to catch it. I'm doing this notionally on another box. There we go. We've wrapped it with a bunch of X's so we can grep it out pretty easily. And now we have his SSH key. Okay, that worked. So a little bit better grepping, and we got an SSH key just by watching the password line. We've had to have been on the other server to do that, of course. So that was cool. Another thing you can do is socketless comms. So if you do not, for whatever reason, want a socket there, there is a socket, of course. There's the packet socket, which you can see in SS if you really ask for it. Netstat, on the other hand, you can't. So I was at University of Wilmington, helping their CCDC team. I think we have Wilmington dudes. There we go. Yeah, I was helping their CCDC team, and they were like, they figured out if they run netstat peanut constantly, they'll see anything with a network connection. And the target had like SSH and FTP or SSH and something. It's like not a rat, basically. And they're like, hey, if it's not SSH and whatever that thing was, kill it. And I was like, well, okay, so I need no socket with network comms. That works. So what I came up with the idea was just I would use PCAP to sniff the network, and if I got a packet that looked interesting, I'd use it. So it's cool. Wrote a tool called PCAP knock. It's on the internet there, source. And what it'll do is just sniff the wire and look for something interesting. It'll look for something that says command, and a command to run, and the word command, or callback, an address to call back to, and a callback. It's nice and injectable. It runs standalone. It's cross-platform. It's not weapons grade. I was talking to a fellow yesterday, and he's like, hey, man, this tool of yours is really great, except when I try to inject it into systemd, and then it crashes the box. And I'm like, it's not weapons grade, but cool. So we're gonna say we already have the log server run compromised. We've got root, and we're going to try and get a callback based on what we can send to the transaction transfer box. So we're us. We're gonna try and log into this box in such a way that the syslogd server will call us back. So there's VIO0. So we're on .42, and we'll SSH to .43 with this address, with this username. Call me back to docket 42, port 4444, and a bunch of things up here to just make less noise. And we got a connection, .44, which is not 43, which we SSH to, not 42. So that's that log server. This was the log entry, by the way. We can see, yeah, we're on there as root. This is our little shell. Knit is something that nobody's ever going to kill, just in case. And it's just shoved in as libpk. So you just shove something in there using PCAP, shoved into a systemd, by the way, to init. Shove it into init, nobody will notice. There we go, that's how we did it. That's the LDS at a preload. So, and this is what it actually looked like on the wire. There was a syslog message that said invalid user callback. That syslog message was on the wire. So PCAP picked it up and used that to figure out what address to call back to. Another thing you can do, bypass a firewall. So I was fiddling around with this, and I realized that PCAP sits outside of the firewall on Linux, Unix. So if I use PCAP to grab something, I can skip over the firewall and inject something into the network stack with a tap device. Also works with a ton device if you just want to go for layer 3. Cobalt Strike does something pretty similar with it does, forget the VPN thing. SSH will do this also for you, just a little more complicated. If you actually want to weaponize this, it's a pretty good first libpcap project. It's fairly simple. So we'll have is the kernel talking, excuse me, the network talking via libpcap, just some userland process, which will shove data into the kernel over tap 0. This also works on OpenBSD. It's pretty trivial to port to anything else, but not much like random people grabbing stuff for OpenBSD off the internet. So our scenario, the same boxes we've been on. FTP isn't working anymore for our access. We've got cred use with SSH, but we still want to open up that FTP again. By the way, you end up doing You end up doing a lot of fiddling with BPF filters in fconfig when you do this. So this is what it looks like. We have the network out here. It'll send data to the NIC. Normally the firewall will drop it and say, no, this isn't something we want. We don't want FTP anymore. But the NIC sends to the process, bypass FW, the tcpdump or libpcap using process, which will send it then into its virtual NIC into a kernel. So it's just a nifty way to hop around a firewall. Looks like this. So FTP no longer works for us. We can't grab Etsy password. We can still SSH in though, so we'll do. Banker Joe will let us in. Same transaction transfer box. And we see that sure enough, we have a block drop in, a default block, and just a pinhole punched for 22. So that's a problem for us. So what we'll do, we'll just put bypass FW on the box, because we can still SSH in, get back on the box. We need to know the MAC address. So this is 64FC is the MAC address for this, the interface that we're going to mooch from and hop over the firewall with. There we go. So we make a tap device, and we'll give it the same MAC address, because the kernel expects things coming from the interface with the MAC address if you're going to give it to it with a MAC address. Sure. There we go. They look pretty similar. Different IP address, but pretty similar. And we'll run it and say, hey, anything coming into, any ARP packet we'd like, anything coming into 1.254. So we sort of functionally now have tap 0 on the network with the address 254. Also another good address, because people are like, it's probably something the network dudes are using. We'll just ignore that. And now we try 254, and sure enough, it works. We get its password down, and hopped over a firewall just easily with that. Last demo is EDR defang. And when I was writing these, I was like, hey, these are all great. They all work on Unix. Most of them work on Linux, which is what you'll find everywhere. I was like, what about Windows? What if I try to write PCAP code for Windows? And the answer is, don't do that. It's not a kind thing to do. So, but I was like, what does Windows give me that's kind of neat and hackerish? And turns out they have a nice API to drop a TCP state from the state table. So you can say, yeah, I know we're doing TCP comms, just forget about it. Not like send a reset, not send a fin, it just like, it doesn't exist anymore. So I was like, hey, if I catch a SYN to something I don't want somebody talking to, I can tell Windows to ignore it, because it'll make a state. And I was just like, hey, no, never mind, we're not doing that. So it's like, well, what is worth dropping? And EDR is worth dropping. So EDR usually nowadays has to call it to some C2 server. That's, dude, these things, it's like, yeah, I can get a shell on your box and do admin stuff, and I can transfer files, and I'm like, that's SSH, that's a rat. What are you doing, dudes? But anyways, so we'll catch a SYN, and as soon as we see it from some defined range that we know the EDR uses, or the other way around, like, we only want this box as the bad guys to be able to talk to us, you'll make your users kind of mad. Like, don't do this if you don't have to, but it works. So we get a SYN, a drop, a SYNAC. The box is like, hey, I have no record of this connection, and a reset. TCP kill is pretty similar, except it forges a bunch of resets, because back then Linux did not have an API for this. So we're just going to watch packets matching the filter, or BPF filter, set TCP entry. The only thing set TCP entry does, in typical Windows fashion, is it drops TCP entries. So I wrote this for Windows. If you're reading my Windows code, I would like to apologize for the lack of Windowsy things. I use functions like open and printf. This is probably something you want to incorporate as another tool. You probably don't want to write, just a standalone tool, but it works. So in this scenario, we'll pretend we found a Windows box after hours. We pretend we don't really know where the management servers are, but what we want to do is just wipe the box. Sort of a corny Sony-ish thing. Source for the EDR sniper, the PCAP-ish tool, and the source for the wiper. The wiper is actually like, don't put it somewhere you don't expect to wipe, but it's a nifty little way to say, hey, you're like super elite AI, ML, AV that detects things before they run. Doesn't. One thing to note about Windows, though, is PCAP sits inside the firewall. So you have the NIC, and it sends data. First it gets firewalled, and then through NDIS, the driver layer, it'll go to your PCAP process. So it's not quite as nice and friendly. You can't do so many crazy things on Windows, but that's what you got. So there is no eskinema for this, just some screenshots. So this is what, I started wiping, started deleting things. I understand that you should not be deleting all these things on Windows, I've been told. And this 7 address here, is gents in the back, can you see that? Gentlemen and ladies in the back, is that? No. This is going to be interesting. Hey, that didn't work. Well, that's cool. I apologize to the people in the back. you'll have to take my word for it, that this address is, and I graded it out, but it's the address of the servers for whatever, I just Googled like best free malware, best free anti-malware 2019 or something, put it on the box, and that was in fact their address, and it's trying to get out. Meanwhile, we're losing loads and loads of data. I've also been told that things in C Windows you shouldn't really remove from a Windows box, and I tried. And the AV was like, hey, C2 server, or AV server, can I let this happen? And the server didn't say anything, so sure, why not? I'm also told that like C Windows system.ini is not something you're supposed to remove. Windows site up, like it worked, and then Microsoft, like Windows itself started calling out to Microsoft addresses. And I was like, maybe we don't do that. So that happened. All right, so in summary, if you're gonna use PCAP, and I recommend it, and it's a neat thing to learn just how networking and how things work under the hood with a little bit of abstraction layer. You got to attach to a device, so either PCAP open live or PCAP create, set, and activate. It's usually good to set a BPF filter. You don't necessarily have to, but if you're going to do it, compile the filter, set the filter, and free the memory. Depending on what you're doing, it's usually good to grab the data link type, and then sniff and inject. Off you go. I'm not going to read this, but it's good reference for how you can compile it. Likewise, reference for how you would execute it. A couple ideas. So it's like, hey, what you know, if I had an intern, what would I say? Hey, intern, here's a cool thing to learn PCAP. So a VPN device, like we showed in a couple demos ago. Take your favorite rat, add EDR sniper. And it's not necessarily a C-specific thing. So if you're using one of the nifty Go frameworks nowadays, add it in there. Weaponize PCAP knock, maybe add some encryption, add some authentication, add some replay protection. A port scanner would be kind of cool, an injectable port scanner, maybe using a different source address so that you own another box and that's where you're getting the syntax or something like that. It'd be kind of cool to get your shell output or exfil or whatever over SYN packets or ICMP or whatnot. All right, so thank you for coming. Any questions? None. That, by the way, is another legit QR code. All right, so is that a hand or was that a, nope, that was a scratching of a neck. All right, well, no questions. Thanks for coming.